Okay, so we're going to be determining if this multivariable equation is a saddle point, and we're going to be maximizing it as it's denoted right there. So our first objective is doing our first order conditions. So I'm going to do D1 to signify that I'm doing the first order condition of x1, and I'm going to do D2 to signify that I'm doing x2. Okay? So this is this is very easy. I'm not going to go over how this is done, but you should be able to master this. Now I'm correct? I was mentioning so I have like my answer sheet here, so I answered this earlier. It's not a good habit to like check over while you're doing a question if you have it right, because it kind of just like lowers your confidence, because you like feel like you have to have your answer sheet. Anyway, so we're just gonna solve for one of these because they're identical. If you hadn't noticed, they kind of like mirror each other. So we're gonna do D1 first. So we're moving this to the other side. Okay, well, all right, so we have two solutions. X is either equal to 0 or x is equal to 1, okay? So we're either maximizing at x1 or x0. Oh, and it's also the case x1 equals x2 equals 1 or 0, okay? I hope this is all being shown on the board right now. Yeah, it is. Okay, we're in business. This is an important fact because this being true, because these are mirroring each other, we also know for a fact x1 equals x2 squared, okay? And so they kind of have to match up like this. And so we know the two solutions are either x equals 0, x equals 1. It doesn't take, you wouldn't be able to put anything else here, okay? Okay, this makes sense so far. I've deemed it so. Okay, so this is where things get a little tricky. So you've kind of, okay, so we can write this up here. Okay, this formula looks like a lot. It's not that difficult. It's just a lot of writing, okay? And in our case, it's actually really easy. I know it doesn't look very easy, but I promise it is very, very easy. In fact, I don't even think I need to look at any of this at all. Yeah, you wouldn't need to look at. Okay, so you're doing your second order conditions to figure out if these points actually satisfy, if they're like indefinite, or like you're trying to find out if your solution is actually satisfactory. We've got two right now. We've got two possible solutions, and right now it's actually not too difficult to tell which one it actually is, but it's much better to do it like this, to kind of go all the way. So this second order condition is doing your first order condition of your x2 twice. And this is the same thing with x1. And because we know these are mirrored, they're going to have the same answer. And I'm going to prove it because why not? And then also these two as well, okay? I'm going to erase the arrows. I don't want things to get too noisy here. So let's do this first. Let's do this corner first. So we're doing the second order condition of this. Okay? Well, our D2, I guess double prime, if this is prime, we can double prime it to show that's a second order condition. It's just going to be negative 6 x 2. Okay? So it's going to look like that. Right? Because this is going to go away. This is going to drop. Your 2 is going to drop. I guess I could have shown more steps, but I really don't feel like I have to. This is obvious, okay? Because your 2's dropping. Your 2's gone now. It's left to the power of 1. It's 2 times less 3. It's less 6, okay? I'm not going to go into detail here. And so this is the exact same shit because you've just got this going on here. Okay, well then, all right, so we know D1 prime twice less 6x1. And because in our solution, x1 is going to equal x2, it doesn't really matter which x it is right now. Okay, it's going to be the same thing. And so these two are also going to reflect the exact same pattern. Again, I'm just going to show it to be the case. So now we're doing this, but now we're worried about x2. Well, the answer is just 3, right? So I guess D1, D2 would be, that looks like a 0 or an O or something. I know this is a stupid notation, but I'm tired. It's 3 a.m. 3, and then D2, D1 is also 3. So we've solved our Haitian, which, again, if you hadn't noticed, wasn't really that difficult. Because it's just easy math. This is not hard math right now. So I forget, yeah, it was negative 6 x2, negative 6 x2, 3, 3. So this is these are our coordinates here. So if we put x0, if x equals 0, guys, this is indefinite. 0, 0 is indefinite because 0, 0, 3, 3. Okay? That's not right. You can't do that. Indefinite. So now we know what the answer is. But what does this answer mean? So let's get rid of this. And let's just, I'm going to just, because we know it's 1 now, so we're just getting rid of x2. And we're getting, I guess that was x1 up there. It doesn't matter. It doesn't matter right now. This is a saddle point. This is a saddle point because some of the, and I'm forgetting the name. I think I have it written down. Okay. This is the rule. Eigenvalues, I believe that's what they're called. Okay. Or that's how they're pronounced. But these sort of values on the matrix here are called eigenvalues. If all the eigenvalues are positive, you're at a local minimum. If all the eigenvalues are negative, you're at a local maximum. Yeah. If all eigenvalues are positive, you're at a local minimum. If all eigenvalues are negative, you're at a local maximum. And if eigenvalues have mixed values, you're at a saddle point. Okay? Mixed signs, right? You've got negatives here and you got positives. So we know we're at a saddle point, which means we're not actually, it's almost like a potato chip, you know? It's down one way, but it's up another. Does that make sense? It's like swooping down. It's like, ooh, how do I picture this for you guys? It's like it's like a saddle. I don't know how else to explain. Like it's going, Pringles chip. like a Pringles chip. You know how like a Pringles chip is? How it like swoops in, but it's got that curve there? It's like a saddle. That's why it's called a saddle point, guys. Come on now. Okay. So yeah, anyways, my solution looks just like my solution from earlier, so we're not really that surprised, are we? So this is definite. We know this is a real solution, so therefore, I should write therefore. The 3 dots, whatever. Therefore, x star is equal to 1, 1. That looks like a 2. It's been a long night. This is our answer, and it is a saddle point. Okay?